again, all 3 satellites headed to Lagrange Point 1, a location 1 million miles from the Earth, to study space weather.
5, 4, 3, 2, 1. Engines full power. And liftoff. Go Falcon, go IMAP, go SWFO-L1, and go Carruthers.
From here on Earth, our sun looks steady and unchanging. But close up, it's a dynamic, active place. Loops of superheated plasma follow tangled magnetic fields across the surface, while a steady stream of electrically charged particles, the solar wind, expands into space in all directions. At times, there are bursts of radiation called solar flares, and explosions of plasma and magnetic fields called coronal mass ejections, sending solar storms racing off into space through the solar wind. On Earth, we live in that constant stream of solar wind, protected by Earth's magnetic field. But when the sun suddenly unleashes massive amounts of energy and material, our magnetic field can go haywire during what's called a geomagnetic storm.
Many times we think of the transition between the atmosphere and space as being this very abrupt boundary where at one altitude you've got atmosphere, and the next altitude you have space. But in reality, this transition is much more gradual and can extend over thousands of kilometers. By imaging the geocorona, we can actually answer fundamental questions about the size of the exosphere, the structure of the exosphere, and how it changes over time. And all of this in response to the input from the sun.
NASA's Interstellar Mapping and Acceleration Probe, or IMAP, NASA's Carruthers Geocorona Observatory, and the National Oceanic and Atmospheric Administration's Space Weather Follow-on Lagrange 1, or SWFO-L1. Now, IMAP is the primary mission of the 3 today. Finally, last week, everything was encapsulated inside Falcon 9's payload fairing. The 2 halves will protect the satellites during launch. And again, all 3 satellites headed to Lagrange Point 1, a location 1 million miles from the Earth, to study space weather.
To their higher orbit.
Fairing separation confirmed.
There go the fairings, and now you can see all 3 spacecraft revealed.
So now our 3 spacecraft.
Well, let's start by talking first about NASA's IMAP. It's about the size of a hot tub and weighs a little less than a compact car at nearly 2,000 pounds. There are 10 science instruments on board, and the instruments will work together to map the heliosphere. IMAP is the primary mission of the 3. It will study the giant invisible shield surrounding the entire solar system called the heliosphere, which helps make life possible on Earth by protecting us from dangerous cosmic rays. IMAP will simultaneously study the sun's activity near Earth and also create the most detailed map ever of the heliosphere's boundary.
Right there, IMAP is spinning
up. There we go. That's that 4 revolutions per minute we were talking about. That is not something that is wrong. That is intentional. And you're looking forward. Any moment now, we could have separation of the IMAP spacecraft.
That is a pretty cool image right there.
IMAP deploy confirmed.
There we go.
We have
IMAP has
deployed.
separated, beginning its mission to map to the solar frontier and reveal how the sun shapes our space environment.
Go IMAP.
NASA's Interstellar Mapping and Acceleration Probe mission, or IMAP, will study the giant invisible shield surrounding the solar system, called the heliosphere. The heliosphere helps make life possible on Earth by protecting us from dangerous cosmic rays coming from across the galaxy. The boundary of the heliosphere, located around 11 billion miles from Earth at its closest point, is hard to study. But that's changing with IMAP. As a modern-day celestial cartographer, IMAP will fill in the blank spots on our map of the heliosphere and help us understand fundamental processes happening across our solar system. The spacecraft will be stationed at Lagrange Point 1, a location approximately 1 million miles from Earth toward the Sun. From that vantage point, IMAP will study our heliosphere, as well as measure the constant stream of particles coming from the sun that can endanger spacecraft and astronauts.
Meet SWFO-L1, NOAA's first purpose-built space weather observatory. When a solar storm erupts from the sun, SWFO-L1's coronagraph observes the event right away and sends the data back to the SWFO ground segment, a network of antenna stations all over the world, with the SWFO Command and Control in Maryland. But spotting a storm is one thing. Actually measuring it close up is another. It's the difference between tracking a growing hurricane on radar and flying through the storm on a Hurricane Hunter aircraft. SWFO-L1 does both. After the spacecraft spots a storm with its coronagraph, it watches the approaching weather and waits. Somewhere between 18 and 70 hours later, the incoming storm passes over SWFO-L1. Then, the spacecraft's instrument suite measures the storm's severity and speed and sends that data home too, giving NOAA early warning somewhere between 15 and 60 minutes before the storm arrives at Earth.
SWFO-L1 is roughly the size of a washer and dryer, while its solar panel is about the size of a door. When fully fueled, it weighs about the same as a large grand piano. It is the first NOAA satellite designed specifically to monitor space weather 24/7, serving as an early warning beacon for potentially disruptive events.
There we go.
SWFO-L1 deploy confirmed.
And then there's Carruthers, the first ever dedicated satellite to continuously monitor the geocorona, or the part of the Earth's outermost layer of atmosphere. It actually glows. And this will offer unique insights into how space weather affects our planet. The mission is named after American scientist Dr. George Carruthers, who invented the camera that captured the first ever pictures of Earth's geocorona. Apollo 16 astronauts placed the camera on the moon back in 1972, and it's still there today.
And so, as we're on that escape trajectory I was mentioning earlier, we are seeing our altitude steadily increase as we move to the Carruthers spacecraft also being deployed.
Carruthers, separation confirmed.
Awesome. There we go.
That is cool. Carruthers separating, beginning its mission to capture the faint ultraviolet glow of Earth's outer atmosphere.